What's up, everybody? Troy Transformation again, here to talk to you about composite transformations. That's where you take a piece of garbage and make it into a sculpture.
No.
First thing we're going to talk about is a composition of transformations. That's when a transformation is applied to a figure and then another transformation is applied to its image. So let's say you're going to start with triangle ABC. This is your pre-image. And what you're going to do here is you're going to reflect triangle ABC over the x-axis or in the x-axis. So A becomes A prime down here, B becomes B prime, C becomes C prime after a reflection in the x-axis. But then to the image, triangle A prime, B prime, C prime, we're going to perform another transformation. We're going to translate it to the left 1, 2, 3, 4, 5 units. So we translate each point to the left 5 units, and you end up with the image of our image, which now we call triangle A double prime, B double prime, C double prime. Notice that instead of being A prime, it's A double prime to let you know that 2 transformations have happened to point A. 2 transformations have happened to point B. 2 transformations have happened to point C. Same thing over here. We start with triangle ABC, which then is reflected over the x-axis or in the x-axis to give us triangle A prime, B prime, C prime, our image of triangle ABC after it's been reflected in the x-axis. We then take this triangle and translate it up 2 units and to the right 1, 2, 3, 4, 5, 6 units to get triangle A double prime, B double prime, C double prime, the image of our image over here. Now, a glide reflection would be the composition of a reflection and a translation. So we just talked about a composition of transformations. It's just doing a transformation to the pre-image and then doing a transformation again to the image. In a glide reflection, it's specifically doing a reflection and then a translation, or doing a translation and then a reflection. Those would be considered glide reflections. Okay, now let's talk about reflecting a figure over 2 lines. So to reflect a polygon over 2 lines, here's what we're going to do. We're going to take triangle ABC and we're going to reflect it over line N or in line N, and then we're going to take that image, triangle A prime, B prime, C prime, and reflect that over line P or in line P. The only thing different about this is we're doing 2 transformations instead of just 1. We're transforming the pre-image and then we're going to transform the image of that pre-image. So everything else stays the same. If I want to reflect triangle ABC over line N or in line N, the first thing I'm going to do is draw a line through each vertex that's perpendicular to line N. So if you recall, in order to do this, you need a protractor and a ruler. So what I'm going to do is I'm going to first, with point B, I'm going to take my protractor and line up the bottom of my protractor on line N and make sure the 90-degree line goes through point B or vertex B. I line up my ruler with the 90-degree line and trace the 90-degree line through point B, through line N, and continue it on the other side. I do the same thing with point C. I line up the bottom of my protractor on line N. I make sure the 90-degree line goes through my vertex at point C. I then line up my ruler with the 90-degree line. I trace that 90-degree line through point C, through line N, and continue it on the other side. Do the same thing with point A. I line up the bottom of my protractor on line N, make sure the 90-degree line goes through point A. I then line up my ruler with that 90-degree line, trace through point C, through line N, and continue it on the other side. Perfect. Next, I'm going to measure the distance from one vertex to line N. So let's start with point A. What is the distance from point A to line N? Well, I'm going to take my ruler, measure that distance, and let's say it's 2 inches. I'm then going to take that 2 inches and measure it on the other side of line N, on that perpendicular line that I drew. And there is where I'm going to put A prime, the image of point A after it's been reflected in line N. Let's do the same thing for every other vertex. So we'll go to C. How far is C from our line of reflection? We measure this distance with a ruler, and then we measure that distance on the opposite side. Point C, if it's ½ inch from line N, then we measure ½ inch on the other side, and we put C prime, the image of point C after it's been reflected in line N or over line N. And then point B, we measure with a ruler. How far is point B from line N? It's 1½ inches. I then measure 1½ inches on the other side of that perpendicular line that I drew to line N, and I put B prime, the image of point B after it's been reflected in line N. We then connect these dots and we have triangle A prime, B prime, C prime, the image of triangle ABC after it's been reflected in line N. But I'm not done. I have reflected triangle ABC in line N, but I'm reflecting it over two lines, over line N and line P. So what I'm going to do is I'm going to take this image and repeat steps 1 through 4 with my image now. So let's start by reflecting C prime. We're going to take C prime and reflect it over line P. So to do that, we take our protractor and we line up the bottom of my protractor with our line of reflection. This time it's line P. So I do that and I make sure the 90-degree line goes through C prime. Now I get my ruler, line it up with the 90-degree line, and then trace the 90-degree line through C prime, through line P, and continue it on the other side. Then I move on to B prime. I line up the bottom of my protractor on line P, make sure the 90-degree line goes through B prime. I line up my ruler with the 90-degree line and trace the 90-degree line through B prime, through line P, and continue it on the other side. I do the same thing for A prime. I put the bottom of my protractor on line P. I make the 90-degree line go through A prime, bring my ruler up to that 90-degree line and trace the 90-degree line through A prime, through line P, and continue it on the other side. Next, I'm going to measure the distance from each vertex to the line of reflection. So if I take a ruler and measure the distance from A prime to line P, and I get 1.3 inches. Then I'm going to take my ruler and measure out 1.3 inches on the opposite side of line P on that same perpendicular line, and I'm going to put A double prime. That is the reflected image of A prime over line P. Then we do the same thing for B prime. I measure the distance from B prime to line P with a ruler, and I get 0.2 of an inch. We then measure that same distance on the opposite side of line P on that same perpendicular line, and we put B double prime, the image of B prime after it's been reflected over line P or in line P. Lastly, I'm going to measure the distance from C prime to our line P, and I get 1 inch. I then measure that same distance on the opposite side of line P on that same perpendicular line, and I put C double prime, the image of point C after it's been reflected over line P. I then connect these dots and I end up getting triangle A double prime, B double prime, C double prime, which is the image of triangle A prime, B prime, C prime after it's been reflected in the line P or over the line P, which is the image of triangle ABC after it's been reflected in the line N or over line N. This is a composition of transformations.
You know what time it is. Example time.
Now example 1 says graph triangle RST with vertices R, S, and T and its image after a translation along the vector -4, 0 and a reflection in the x-axis. So we're doing a composition of transformations, just this time it's on the coordinate plane. So we're going to start by graphing triangle RST. So we graph each of these points. Point R is at 1, 2. We go over 1 on the x-axis, up 2 on the y-axis, put a point. Point S is at 5, 2. We go over 5 on the x-axis, up 2 on the y-axis, put a point. Point T is at 3, 5. We go over 3 on the x-axis, up 5 on the y-axis, put point T. There's our triangle RST. We're also going to graph its image after a translation along the vector -4, 0. Now we know it's a vector because of these brackets right here. And what is it telling you to do? Well, we can think about it two ways. We can think about it as how are we moving each point on the coordinate plane, or we can think about it as to what are we doing to each coordinate in the ordered pair. Well, first way, how are we moving each point? This first number tells you where to move the points left or right. So if it's -4, it's telling you you're going to move each point to the left 4 units. The second number tells you how much to move up or down. Since it's 0, you're not going to move up or down any. So we're basically just moving each point to the left 4 units. You could also think about it in terms of what you're doing to the ordered pair, or in function notation. You are subtracting 4 from each x coordinate and then adding or subtracting 0 from each y coordinate. So the y coordinates stay the same, the x coordinates you are subtracting 4. So let's go ahead and move each point to the left 4 units. We're going to take R and move it to the left 4 units and put R prime. We're going to take point S and move it to the left 4 units and we put S prime. We then take T, move it to the left 4 units and we put T prime. This is triangle R prime, S prime, T prime, the image of triangle RST after it's been translated along this given vector. Now, we're going to put the image of triangle RST after it's been reflected in the x-axis. So where's the x-axis? It's right here. Now, when you're reflecting over the x-axis or the y-axis, there's 2 ways to do it. One would be to just count how far R prime is away from the x-axis on this side, and then count that same number of units on the other side and put R double prime. Or you can think about it in terms of the cheat code. When you reflect over the x-axis, you just make the y value the opposite of whatever it is. So instead of being -3, +2, R double prime is going to be at -3, -2. Instead of S prime being at 1, 2, S double prime is going to be at 1, negative 2. Instead of T prime being at 1, 5, T double prime is going to be at 1, negative 5. There is triangle R double prime, S double prime, T double prime, the image of triangle R prime, S prime, T prime after it's been reflected in the x-axis, which is the image of triangle RST after it's been translated along this given vector. The last thing I want you to ask yourself is this a glide reflection? Well, remember, what is a glide reflection? It's any composition of transformation that includes a reflection and a translation. Well, we have a translation and we have a reflection. Therefore, yes, this is a glide reflection.
It's time for you to try.
Okay, doing the same thing here, except this time we have a rectangle LMNO. So here are the vertices of rectangle LMNO. We're going to go ahead and graph these vertices. L is at negative 1, 2, so we go over negative 1 on the x-axis, up 2 on the y-axis, put point L. Point M is at negative 5, 2. We go over negative 5 on the x-axis, up 2 on the y-axis, put point M. Point N is at negative 5, 4. We go over negative 5 on the x-axis, up 4 on the y-axis, put point N. And point O is at negative 1, 4. We go over negative 1 on the x-axis, up 4 on the y-axis, put point O. There's our rectangle LMNO. And we're going to graph its image along the vector 5, negative 2. Again, it didn't have to say it was a vector. We know it's a vector because of these little brackets right here. What is this vector telling us to do to each of these points? Well, again, remember, the first number is telling you how many units to move each point, left or right. Since it's positive, we're going to move to the right, and we're moving right 5 units. So we're going to move each point to the right 5 units. The second point tells you how many units to move the points up or down. So we're going to move each point down 2 units. So we're going to do the right 5 units and down 2 units. Or we're adding 5 to each x coordinate and subtracting 2 from each y coordinate, however you want to look at it. So let's do it. We are going to move each point to the right 5 units and down 2 units. So point L, we're going to the right 5 units and down 2 units. There's L prime. Point M, we are going to move to the right 5 units and down 2 units. There's M prime. N, we're going to move to the right 5 units and down 2 units. There is N prime. And then O, we're moving to the right 5 units and down 2 units. There is O prime. Here is the image of rectangle LMNO after it's been translated along this given vector. But we're not done. We're also going to graph the image of this now after it's been reflected in the y-axis. So to reflect in the y-axis, there's 2 ways you could do this. The first is that you can count how far each point is away from the line of reflection. So O prime is 1, 2, 3, 4 units away from the line of reflection. Therefore, O double prime is going to be 1, 2, 3, 4 units on the opposite side. Or you can remember the cheat code for reflecting in the y-axis or over the y-axis. It's just making the x-coordinate the opposite of whatever it is. Let's start with point L prime. Point L prime is at 4, 0. So I can either count 4 units on this side and then 4 units on this side, put L double prime, or I could have just made that negative 4 and L double prime is at negative 4, 0. M is at 0, 0. It is on the line of reflection. Therefore, when you reflect it, it stays exactly where it is. So M prime is the same point as M double prime being reflected over the y-axis or in the y-axis because it's on the line of reflection. N prime, the exact same thing. It's on the line of reflection. So when you reflect it, it just stays on the line of reflection. There's nowhere to move it. It's on the line of reflection. And then O prime is 1, 2, 3, 4 units on this side. So we count 1, 2, 3, 4 units on this side, put O double prime, or we could have just made that 4 a negative. You get negative 4, 2. That's where O double prime is. So now we have our rectangle, L double prime, M double prime, N double prime, O double prime, which is the image of rectangle L prime, M prime, N prime, O prime, after it's been reflected in the y-axis, which was the image of rectangle LMNO after it was translated along this given vector. That's why it's a composition of transformations. Lastly, we're going to ask you, is this a glide reflection? Well, we did have a translation, which is the glide, and then a reflection over the y-axis, which is our reflection. So yes, it is a glide reflection. Example 2 says graph triangle LMN with these given vertices and its image after a reflection in the x-axis and a rotation of 90 degrees clockwise about the origin. So we're doing another composition of transformations. First step here, again, graph your preimage. So it's triangle LMN. So we start by graphing point L at 4, 5. So we go over 4 on the x-axis, up 5 on the y-axis. Put our point L. M is at 8, 5. We go over 8 on the x-axis, up 5 on the y-axis. Put point M. N is at 6, 8. We go over 6 on the x-axis, up 8 on the y-axis. Put point N. There's our triangle LMN. That's our preimage. Now we're going to graph its image after a reflection in the x-axis. Remember, to reflect over the x-axis, you can either count 1, 2, 3, 4, 5 units on this side, so we count 1, 2, 3, 4, 5 units on the other side. Or you could remember the cheat code, which is to make the y-coordinate the opposite of whatever it is. So instead of L being at 4, 5, L prime is going to be at 4, -5. Instead of M being at 8, 5, M prime is going to be at 8, -5. Instead of N being at 6, 8, N prime is going to be at 6, -8. There is triangle L prime, M prime, N prime, the image of triangle LMN after it's been reflected in the x-axis or over the x-axis. But we're not done. We are also going to rotate this triangle, now this image, 90 degrees clockwise about the origin. Well, if you recall, a 90 degrees clockwise rotation is the same as a 270 degree counterclockwise rotation, which just means you're going to take each ordered pair and you're going to flip the x and the y coordinate, and you're going to make the x coordinate the opposite of whatever it was. So let's rotate L prime 90 degrees clockwise. To do that, we're going to switch the x and the y coordinates. So it's going to be at -5, 4, but we have to make that x coordinate the opposite of whatever it was. So instead of being 4, L double prime is going to be at -5, -4. So to graph that, we go over -5 on the x-axis down -4 on the y-axis, put L double prime. To get M double prime, we take M prime. We're going to switch the x and the y coordinates. So it's going to be -5, 8. But we have to make that 8 the opposite of whatever it was. So it's going to be -5, -8. So we go over -5 on the x-axis, down -8 on the y-axis. There is M double prime. To get N double prime, we take N prime, this ordered pair, and we switch the x and the y coordinates. So it's going to be -8, 6. And then we make that x coordinate the opposite of what it was. So we make it -8, -6. And that's where N double prime is going to be. So we go over -8 on the x-axis, down -6 on our y-axis. There is N double prime. Here is our image of triangle L prime, M prime, N prime after it's been rotated 90 degrees clockwise about the origin. And this was the image of triangle LMN after it was reflected in the x-axis. So we now have a composition of transformations. Last question, was this a glide reflection? Well, we did have a reflection, but we had a rotation after that. Because there was no translation, there was no glide. So this would not be considered a glide reflection.
You better try this right now!
Okay, doing the same thing here. First, we want to graph triangle ABC. So let's start with point A. Point A is at -4, 2. We go over -4 on the x-axis, up 2 on the y-axis, put a point. Point B is at -8, 5. We go over -8 on the x-axis, up 5 on the y-axis, put our point B. And then point C is at -8, 2. We go over -8 on the x-axis, up 2 on the y-axis, put point C. There's triangle ABC. Now I need to graph the image of triangle ABC after it's been rotated 180 degrees about the origin. And if you recall, the cheat code for rotating a point 180 degrees about the origin is to change the x and the y coordinate in each ordered pair to the opposite of whatever they are. So if I want to rotate point A 180 degrees about the origin, instead of A being at -4, 2, A prime is going to be at +4, -2. So I go for +4 on the x-axis, down -2 on the y-axis. There's point A prime, the image of point A after rotating it 180 degrees about the origin. If point B is at -8, 5, then B prime is going to be at +8, -5. So I go over +8 on the x-axis, down -5 on the y-axis. There's B prime, the image of point B after rotating it 180 degrees about the origin. C is at -8, 2. So if I want to rotate C 180 degrees about the origin, I take -8, make it the opposite, so it's going to be +8. I take 2, make it the opposite, it's going to be -2. So C prime is going to be at +8, -2. So I go over +8 on the x-axis, down -2 on the y-axis. There is C prime, the image of point C after rotating it 180 degrees about the origin. Here is our triangle, A prime, B prime, C prime, the image of triangle ABC after rotating it 180 degrees about the origin. Lastly, I want to then reflect this triangle in the y-axis. So to reflect it in the y-axis, what I'm going to do is I can either count the distance each point is away from the y-axis and then count that same distance on the opposite side of the y-axis. Or I can remember the cheat code, which is just to make the x-coordinate the opposite of whatever it is. So if A prime is at 4, -2, then A double prime is going to be at -4, -2. If B prime is at 8, -5, then B double prime is going to be at -8, comma, -5. And then if C prime is at 8, comma 2, then C double prime is going to be at -8, comma, -2. And there is triangle A double prime, B double prime, C double prime, the image of triangle A prime, B prime, C prime after it's been reflected in the y-axis, which was the image of triangle ABC after it's been rotated 180 degrees about the origin. Last question, is this a glide reflection? Well, there was a reflection, but there was no glide, there was no translation, there was only a rotation. Therefore, this was not a glide reflection. Now, example 3 says describe the transformations required to go from the blue preimage to the red image. So here we have our blue preimage with this duck or frog footprint, and we're going to this red image of the same footprint. So how do I get from here to here? Well, clearly I have to slide this up. And to slide something up, that's called a translation. So I would require a translation to get up to this point. And then to go from here to here, I would then need to flip it or reflect it over some given line. So it would require a reflection over a given line. So to get from our blue preimage to our red image, this would require a glide reflection, or a reflection in a translation, or a translation and a reflection. As for part B, I can't really see myself reflecting this, because if I were to reflect it, it wouldn't have this orientation right here. You see how this is a little darker blue over here and this is a little darker blue over there? So if I were to reflect it, the darker blue should be on this side. So this would actually require a rotation of some kind. And then after I rotate it around a given point here, I could then slide it this way, and that would give me my image shell over here. So this would require a rotation and a slide, or a rotation and a translation to be more specific.